Okay, so what I'm going to tell you about are stem cells. So what we are going to imagine is that this is our stem cell, yeah? So what we are thinking about is what we can do with this stem cell and what potential it has. So if I'm taking this stem cell and I were to crack it into here, and then considering that it's lunchtime, I might want to give it a whisk. I might want to let you give it a whisk, but we can whisk up this stem cell. And so now we've started to change the stem cell. We're changing it to something different. And as scientists, if I now said to you, right, I want you to put this stem cell back together with the yolk and the egg white and the shell, do you think this would be possible? Is it possible?
Not as an egg, no.
Not as an egg. So, and even as a stem cell, we would think that was an impossible thing to do. But actually, there's a Japanese scientist that a few years ago won a Nobel Prize because he managed to do that. He managed to turn something that wasn't a stem cell back into a stem cell. And that technology has been very important for us as stem cell scientists. So what we normally do is we take our stem cells and we are effectively then glorified cooks, because in our laboratory what we do then is add different things to our stem cells. So if it was lunchtime, we were fancying something savoury, we would be adding what type of things maybe to our eggs to make something nice for our lunch. Peppers, bacon, ham, whatever, cheese, and we then might make an omelette. Yes? But equally, we could take the same starting material and we could add different ingredients. So say it's tea time. Fancy something sweeter. What could we add to make something suitable for our tea? Flour and sugar. Look, we've got a male chef here. I've got all these girls here. Come on. Fantastic. So flour, sugar, and all the rest of it. So we could be making a cake. So clearly, we can add different things to make different, with our sort of same basic ingredient, and then we're going to make different things. And essentially, it's as simple as that. When we come into our laboratory, that's essentially what we're doing. Now, where do you think we could be getting the stem cells from? Because we are not doing research on embryonic stem cells. There was a clue here. There's a clue in the bone. So yes, we're doing a lot of our research on stem cells from the bone marrow. And actually, these stem cells are what sometimes referred to as adult or tissue stem cells. And in fact, within the bone marrow, we've got two types of stem cells. And you wouldn't know, looking at them, that they were different. But when we add some ingredients to this one, we can get a whole variety of things. We can get our white cells, and these are white blood cells, or our red blood cells, or platelets that we have in our blood. And if we take the other ones, we can turn them into some other interesting things like fat, if we ever wanted to make fat. We can also turn them into bone, or we can turn them into cartilage. Oh. So that means that we can start to make things with these stem cells. So we can take stem cells out of bone marrow and we can start to make cartilage, which means that we could start to treat diseases like arthritis, where you've got problems with your cartilage, or we could make bone, so if somebody needs a bone repaired. And obviously, the stem cells that make the blood are what we already use for stem cell transplants, for bone marrow transplants, if somebody has a blood cancer. And so when people tell you stem cell therapy and stem cells being used in the clinic is something of the future, we've actually been doing that for 40 years, giving people bone marrow transplants. But we are hoping that in the future we'll be able to do a lot of other interesting things with stem cells to treat people with a lot of other different diseases. Thank you.